Next, we will visualize the flow around the turbine by adding some streamlines. Up in the toolbar, we'll click the streamline icon, and we're going to name it Velocity Streamline. Now we'll tell it to start the streamlines from the inlets. So for start from, click on these three dots, and this lets you choose multiple surfaces. We're going to select both of our inlets. You can use the shift key if you want. Okay. We now have the option of choosing the number of streamlines to display. I think 200 is a good starting point. Now change the variable to velocity in standard frame. This sets our frame of reference to be the ground and not the turbine blade when looking at these velocity streamlines. Now in the color tab, change the range to user specified and type in 9 meters per second for the min and 13 meters per second for the max. You can obviously play with the colors yourself, but I found these to make it graphically intuitive. Okay, so we're all set. We'll click apply. Alright, isn't that cool? So I preferred to look at the wireframe as well. Makes it easier to see our domain. So here are a few important things to take out from these streamlines. So first, you can see that the inlet has this yellow color, and from the gradient here we can see that it's 12 meters per second, so this is what we specified. Next, there is a clear drop in velocity behind the turbine, and this is definitely the correct behavior as it's showing the wake behind the wind turbine. Finally, there is a clear acceleration of the flow around the wake, and this is shown by the more orange-like color here. Perhaps we can better see it from this angle. Yeah, like here, all around it. This is also what is expected from mass and momentum balance. So this behavior matches actually the actuator disk model of a wind turbine quite well. You can obviously play around with the way you want to display these streamlines, and you might also want to consider not using the inlet top surface to better see these results.